In this video, I will walk you through the 5 steps you can take to solve number series questions on your test. The first step in any number series question is always going to be finding the difference between each pair of numbers, or subtracting each number from the next number. By finding these differences, we can quickly identify the most common type of pattern, which is arithmetic pattern. So if we find these differences here, the difference between 22 and 19 is minus 3, 19 and 16 is minus 3, and 16 and 13 is also minus 3. So we have an arithmetic pattern of subtracting 3 between each number, and so we can apply that pattern to 13 to find 13 minus 3, which is 10, the next number in our series. Let's try an example that doesn't have an arithmetic pattern. Let's say we applied step 1 to this example here. We would have, taking this difference, we would have a difference of plus 1.5, then a difference of plus 6, and then plus 24. There is no discernible pattern between these additions, so we need to try something else. We need to move on to step 2 of our test question strategies, which is looking for geometric changes. So looking for patterns that involve either multiplication or division. So if we instead look at this as what could we be multiplying to 0.5 or dividing 0.5 by, and the answer is we're multiplying this by 4. 4 times 0.5, or 4 times 1/2, its fraction equivalent, is going to give us 2. 2 times another 4 will give us 8, and 8 times 4 will give us 32. So now we have a consistent pattern of multiplying every number in the series by 4, which means we can apply that to the last number in our series. 32 times 4 will give us 128, the next number in our series. Let's say you have another example that doesn't follow an arithmetic or a geometric pattern. What would you do then? Let's take a look at our third example here. If we were to find the difference between each pair of numbers following step 1, then what we would do is find the difference here, which is plus 1, here, which is plus 2, plus 3, and plus 4. Because these are not all the same differences or additions, we cannot say it's an arithmetic pattern. And there's no multiplication or division happening here, so there's no geometric pattern. But what we can do now as a part of step 3 is find the differences between these differences. So what's the change from plus 1 to plus 2? Well, that's plus 1. What's the difference from 2 to 3? Well, that is also going to be plus 1. And here I'll do it inside the arc so it's a bit easier to see. Plus 1, and between 3 and 4 is another plus 1. So now we see a consistent pattern. This is a gradual change pattern where we are gradually changing the number that we are adding or subtracting to this number series. So if we want to find the difference, this last difference here, we need to take 4 and add 1, which will give us plus 5 in this slot. So now to find the next number in our series, we take 10, add 5, and we get 15 as the next number in our series. Let's do another example. In this example, if we were to find our differences between each pair of numbers, we would have a difference of minus 40, a difference of minus 20, and then a difference of minus 10. There is no arithmetic pattern going on here and no geometric pattern. So let's find the differences between our differences by using step 3 of our test-taking strategies. If we find the difference between 40 and 20, we'll see that we are dividing 40 by 2. And 20 divided by 2 will also give us 10. We are gradually changing the difference applied to each number in our number series by dividing the difference by 2. So if we want to find the next difference, we would need to divide by 2 again. 10 divided by 2 would give us 5. So we're going to subtract 5 to find our next number in the series. 30 minus 5 will give us 25, the next number in our series. If you work through steps 1 through 3 and you still find yourself stuck, then it's time to start considering if there's possibly an alternating or combined pattern going on here. Let's take a look at a few examples. For example 1, the difference between -1 and -2 could be either -1 or times 2. So we'll keep that in mind. -2 to 1 would be +3. 1 to 2, in this case could be plus 1 or times 2. The fact that times 2 is consistent between these two steps makes me more inclined to believe that this might be a geometric pattern going on over here. So I'm going to erase these. We're going to say times 2 times 2. Then 2 to 5 is plus 3. 5 to 10 is times 2. So this definitely shows that we are doing a geometric pattern. That big jump in numbers will tell us we have a geometric pattern going on. Then for 10, how do we know which pattern we should follow? We kind of have two different alternating patterns going on. We have times 2 every other pair of numbers, and we have plus 3 every other pair of numbers. So these are two different patterns that are alternating between each other, and they're alternating consistently. So if the last pattern was geometric, that means the next pattern is going to be plus 3, which will give us 10 plus 3, or 13 as the next number in that series. Let's take a look at another example. In example 2, we have 2 to 4, which is plus 2, 4 to 6, which is also plus 2, 6 to 8, which is another plus 2. Then we have 8 to 11, which changes plus 3, plus 2, and plus 4. So there's some kind of combination of patterns going on here. I notice that we definitely are adding to, we are adding to every other pair of numbers starting here. So we can assume that we should also be adding 2 in the next pair of numbers. So over here, so the next number in our series would be 17 plus 2, which is 19. But what is this other pattern that's going on? What is this other pattern we're alternating with? We have plus 2, then plus 3, then plus 4, which means we have a gradual change. We're taking that difference, plus 2 to plus 3, and adding 1. 3 to 4 is a plus 1 to that difference. So let's say, hypothetically, we needed to find another number, the next number in the series. That means we would need to increase our difference by 1 again to plus 5 and add 5 to 19 to get 24 as the next number in that series. Now let's take a look at example 3. 3 to 0 would be minus 3. 0 to 5 is plus 5, then plus 2, then plus 0, then plus 7. This looks like a very random array of patterns. I'm not really making too much sense out of this. If you go through all of your steps up until step 4 and you come across a pattern like that where the differences all seem very random, I want you to try to label every other number starting with the first one and find patterns between those numbers. So the difference between 3 and 5 is plus 2, and the difference between 5 and 7 is plus 2. So now we're on track. If we were to apply that same difference to the next odd number in that sequence, then we would have 7 plus 2, which would give us 9 as the next number in that series. Now, what's happening with the other set of numbers? What about 0, 7, and 14? Well, the difference between 0 and 7 is plus 7. The difference between 7 and 14 is another plus 7. So hypothetically, if we needed to find another number past 9 right here, we would take 14, add 7, and get 21. This is a combination of two completely different number series that are just interwoven together. What really should happen is that we should be able to lay them out consecutively like this. That's one number series. And the other number series was 3, 5, 7, and 9. But these are just spliced together. They're put in between each other. Let's take a look at another example like that. Example 4 is the same way, where if we were to take the normal difference between each pair of numbers, plus 1, plus 0, plus 2, minus 1, plus 5, minus 4, we would see we have a very random array of differences. So let's try that trick. Let's try labeling every other number starting with the first number. And let me actually change that color so it'll be a bit easier to see, because this will extend past our mystery number, and find the differences between those. 0 to 2 would be 1 to 2 is plus 1, 2 to 3 is plus 1, 3 to 4 is plus 1. So to find the next number in our series, we would need to add 1 again. 4 plus 1 will give us 5 as the next number in our series. Then if we go back to our other set of numbers, interwoven between the other set of numbers we just talked about, we have between 2 and 4 is plus 2, and then 4 and 8 is plus 4. And actually, now that I'm looking at that a second time, this is more than likely a geometric pattern rather than arithmetic. 2 times 2 gives us 4. 4 times 2 gives us 8. So to find the missing number in the series, we need to do 8 times 2, which would give us 16. Again, this pattern should really look like this. 2, 4, 8, 16 interwoven with 1, 2, 3, 4, and 5. The only difference is that every other number is interspersed into the other pattern of numbers. If you have gone through steps 1 through 4 of our test-taking strategies and you are still stuck and unable to find the answer, then it's time to consider our most rare number sequences or our special cases. These are numbers that follow our exponent patterns like square numbers or cubed numbers, that follow prime number patterns, or follow the Fibonacci sequence. So let's take a look at example 1. If we look at example 1, the differences between each of these numbers don't follow a discernible pattern. We have plus 3, then plus 4, then all of a sudden it's up to plus 7. And there's no geometric sequence either, nor is there an alternating pattern. So we have to go to step 5 and think about, could this be a square, cubed, prime, or Fibonacci? And the answer is that it is a square pattern. We have 1 squared is equal to 1, 2 squared, which is equal to 4, 3 squared, which is equal to 9, and 4 squared, which is equal to 16. Then the next number in our series would be 5 squared, which would give us 25. For example 2, again, the differences do not follow an arithmetic, geometric, gradual change, or an alternating combined pattern. But what it does follow is the Fibonacci sequence, because each number starting after the first two numbers is made up of the sum of the previous two numbers. So if we take a look at 5 and 3, if we were to add these two together, we would get 8 as our next number. Then if we add 5 and 8 together, we get 13 as the next number in our series. If we add 8 and 13, that sum will give us 21, the next number in our series. So to find the missing number in our series, we must add together the previous two numbers in the series. So 13 plus 21 will give us 34, the missing number in our series. Our final tip for this video is to try and solve these number series questions without looking at the answers first. If you glance at the answer options too soon, you may waste time trying to fit a pattern to each choice rather than identifying the actual rule. So work out the solution first. Once you have a guess, you can check the options. If your answer appears, you've likely found the right logic and saved time second-guessing yourself. But if you cannot find the correct answer, that's always a clue for you to go back and retry the sequence and maybe try looking for other patterns of logic by using the other steps mentioned earlier in this video. There are, however, some instances where it may help to look at the answers if you are really stuck. If you can't identify a clear pattern, like with this example, we have a difference of plus 2, then minus 6, plus 2, minus 4, and then plus 2. You can identify here that there is two alternating patterns. We have plus 2, and then we have a gradual change. Minus 6, decrease that by 2, minus 4. So we would likely decrease it by 2 again here, right? And that would give us the answer choice 4. But let's say our answer options are A, B, C, and D. And our answer choices are 3, 5, 6, and 8. This is an instance where if you look at your answer choice, you can see that 4 is not an option, so we need to reevaluate. What if instead of subtracting in every other number, we are maybe instead dividing? Maybe this could be geometric. Let's try dividing 12 by 2. We would get 6. Then we would add 2. If we divide 8 by 2, we would get 4. Then we would add 2. This is a much more consistent pattern. So then here we would need to divide 6 by 2 in order to get our answer. And if we bring those answer choices back up, we would find that, we would find that 3 is among those options, even though 4 was not. And now we can find our correct answer. In summary, number series problems are all about pattern recognition. By following these 5 streamlined steps and using the answer choices wisely, you'll solve most sequence questions faster and more accurately. With practice, you'll recognize common patterns and become much quicker at spotting the solution. And no matter what, if you exhaust all of these steps and you are still stuck on your question, skip it and return to it later, because sometimes the solution is more obvious with fresh eyes. Good luck, and we'll see you in the next one.